Hi, my name is Giovanni and I'm gonna talk to you about classification. Classification is has many like the six kingdoms. The six kingdoms are what Aristotle said that he was talking about the six kingdoms. It's about like the animals and the humans separated. Another thing is phylogeny. That is the evolutionary relationship between different species. So, phylogeny is that. Always remember that the six kingdoms are phylogeny is about the six kingdoms. So what I teach here is about the six kingdoms. What do archaea and bacteria have in common? Yeah. Archaea and bacteria are in common that they don't have cells, nucleus cells. So that is another thing. Bueno, ahora ya no voy a escribir. Why weren't archaea classified? Archaea weren't classified because scientists didn't know they existed. How are fungi different from plants? Plants make their own food. Okay? If you wanted to find archaea, where would you look? Where would you look for archaea? On the forest floor? No. On the leaves of plants? No. You would look in trenches at the bottom of the ocean because archaea is there. Bacteria are omnipresent on Earth. What does this mean? They can be found practically everywhere. So that is mostly all of the six kingdoms. Okay. Now I'm gonna talk about more of the real classification. Which rank contains the large number of organisms? If you know, there's the class there, and the one that contains more, it's from genus, species, class, or order. What do you think is the one more? Think a little bit and then answer it in your mind. Well, it's class, because class is on the bottom, is on the top. So, the name Tursiops truncatus includes which of the following ranks? Genus and species, kingdoms and phylum, class and order, or species and subspecies? Think. Well, genus and species, because the Tursiops is genus and Truncatus is species, so that's why. Which of the following is true? They can breed with one another of the taxonomic class, or they have certain physical features in common. Think a little bit. Is that they have physical features in common because they can have like more. So how is the domain rank different from the other rank? Look, if you see here, venga. See here, domain comes first, then kingdom, then phylum, then class, order, family, genus, and species. So, what is dominus? It comes first. So, domain comes first. Okay? So, that is all for classification. Thanks for watching. Now I will present you Dr. Manuel Ruiz, the president of the Natural Selection Society.
Hello, Dr. Gianni.
How are you?
Very good, and you? Oh, I did an investigation and I support the natural selection. And these are some examples why I support it. Look, my name is Dr. Manuel and I'm the president of the National Junior Society.
The National Junior Society?
Yes,
Also?
that also involves us a natural selection society. Okay, this is what I investigated and I'm going to tell you. Scientists have investigated that all species make a lot of babies. That some survive, some don't. So the babies, when they survive, they can reproduce. You understand me? Okay. When they reproduce, they have a possibility of their kids have the same trait as them.
One question. How they reproduce?
They reproduce when a male and a female get together and love each other.
But how? They love each other. Like, I love you and already?
No. And come on. It's easy when when two people love, they just reproduce and have new babies.
Okay.
Okay, look, if the next generation has the same trait and it's very successful, it may create a new species. So that states that when a baby has differences from their father and mother and they're successful and they reproduce, if they reproduce again and they have the same trait, it would equal the same species. Like this states right here.
So, tell us, overproduction? Okay.
Okay, what's the question, Dr. Gianni?
¿Cuál es la pregunta? The variation. What is variation?
Variation is when the DNA it has different traits, like the different traits they have from the father and mother, and the kids have their own traits. Next question.
And overproduction. We know what is reproduction, but not overproduction.
Overproduction is when there are a lot of babies and some need to die by the Mother Earth, because if all the birds with success, birds are an example, if all the birds will success, there will be overproduction and there would be a problem in Earth. That's why I'm saying.
Now let's change hobby. Let's change.
Thank you very
But wait. What is your favorite thing to do?
My favorite thing is math. Okay. Thank you very much.
Okay.
And that's not the topic. Now.
Thank you.
Bye.
Bye.
Dr. Gianni.
Bye.
Hi, my name is Max Duque. Today I'm gonna talk about intelligent design. So please join me. The theory of intelligent design holds that certain features of the universe and of living things are best explained by an intelligent cause, not an indirect process such as natural selection. It says that things evolve and that things because someone wants, not because fate of because it happens, like natural selection. Through the study and analysis of a system's components, a design theorist is able to determine whether various natural structures are products of chance, natural law, intelligent design, or more combination theory. Such research is conducted by observing the types of information produced when intelligent agents act. Like if the when something evolves, the scientists want to find evidence that it didn't happen. It happened by an intelligent cause, not you know. Scientists then seek to find objects which have those same types. So they look for another species or another type of animal to support evidence about the intelligent act. Scientists then seek to find objects which have those same types of informational properties, which we commonly know come from intelligence. Intelligent design has applied the scientific methods to detect design. So thank you very much.